On this next example, we're going to be looking at average velocity. Okay, so our example, it says the position s of t of an object at t seconds moving along a line marked in meters is given by s of t equals 2t squared. So what it is asking us to do is find the average velocity from 1 to 1.5. Okay, so average velocity. And what it really wants is average rate of change. And do you guys remember what average rate of change is? That is your good old school slope. Okay, so that's slope. We typically refer to it as old school because when we find slope, the old school way is it's y2 minus y1 all over x2 minus x1. Okay, so if I'm asking you for average velocity, it is the average rate of change, okay, which is our slope. And they're giving us 2 points. So in order to find the slope, I need to come up with my 2 points. The way I do that is I take each of these values and figure out the position. So I would do s of 1, which will equal 2 times 1 squared, which is 1 squared is 1 times 2, so 2. So this gives me the point 1, 2. Then I have to find my other point, which is 1.5. So s of 1.5. And so we would plug in 1.5. So it's 2, we got 1.5 squared. So 1.5 squared times 2 gives me 4.5. So this is really giving me the point 1.5 comma 4.5. I know you guys know how to find slope once you're given the 2 points, but we also need to set this up in function notation. Okay, so the way you guys typically used to find slope was your y2 minus y1 all over x2 minus x1. And so I want you to be able to know how to put this into function notation. It is super important for you to be able to do this, okay? If you have a test, you will need to rewrite this out in function notation, okay? So my y values, this is my function notation. When I plug in s of 1.5, I got my y value out. So I would do s of 1.5 minus s of 1 all over, now it's our x values. What were the x values we did? 1.5 minus 1. Okay, so this is our setup, and it's super important that you guys write out the setup for each one of these. Okay, and now from here you can just fill in the numbers. So s of 1.5 is 4.5 minus s of 1 gives me 2 all over 1.5 minus 1, so 0.5. So I am left with 2.5 over 0.5, which is 5. Now we need to talk about what is the label on this, okay? We have our y values over our x's, okay? The x's are pretty easy to know. X's are labeled in seconds, so the bottom is seconds. So we got seconds. The harder part is, what are my y values labeled as? Okay, well, we plugged in those numbers to this equation. What does this equation represent? It's the position of an object at t seconds, so we already got the seconds, moving along a line marked in meters. So it is, the y's are representing meters. So what this is saying is meters per second. So the velocity is speed. How fast is that object moving from 1 to 1.5 seconds? It's moving at 5 meters per second on average. So that is our average rate of change.